Welcome to Krome Cast. Check it out. I'm Sam Major, Commercial Director of Krome Technologies. I'm joined today by Paul Edwards, Head of Security Operations.
Thank you, Sam.
No problem. So on this episode, we're talking or following on from our recent podcast on security operations, stroke MDR, etc., etc. And we said we'd do a bit of a follow-up and look at some of the technology that we're using to run our SOC. And Paul, very kindly today, is going to show us, hopefully not a real attack, I'm assuming it's a simulated attack. Great, yes. Okay, that's nice and safe. But also, before we dive into looking at, and it is very cool, some of the tech and how it works and operates, there has been, and we should acknowledge it, a bit of a recent, someone spent some marketing funds at Darktrace. They have a new logo, and just to confuse people like me, they've changed the naming convention of everything, and I now no longer know what anything is. So it would be good actually, if it benefit our audience, if we could talk about what I knew as kind of Antigena Network and all the other modules, I guess, what they're now called.
Yes, so Antigena, it's still listed as Antigena in the product itself, but it's now.
So what we'll see today will still be.
Exactly.
So confusingly, they've changed the name, but not in the product as yet.
Yes, it's now known as Darktrace Respond,
or
Respond Network, but it's still labelled as Antigena within the Darktrace interface itself.
Okay, and there's, I'm going to forget these, you might have helped me. There's Respond, Detect. There's two more, and I can't think of. I know one is Heal, which isn't actually out yet.
That's coming soon.
Kindly suggest coming soon, but we'll have to look forward to.
And
Prevent. Thank you very much. Yeah, which is quite cool. And I think we'll save that for another episode. But I think at some point it'd be good to just talk about how that addresses other security threats. But today we're focusing on what was Antigena Network, which is now Respond
Network.
There we go. And yeah, it'd be good, I guess, to just, if you can talk through, before we dive into see the demo, as it were, if you can talk us through kind of what you've set up before we go into simulation, people know what we're looking at here.
So we've got a Kali Linux VM, which can be used to simulate many different types of attack. We're just going to be looking at kind of the very early stages of an attack today. So someone getting onto the network, doing a little bit of reconnaissance, finding out information about what assets you have on your network, and some little bit of identification. So someone trying to work out what OS something's running. So very early stages, the reconnaissance stage of an attack.
So this is where, excuse me, but someone on the outside looking in is, I guess, looking in the ether for vulnerabilities that they can exploit, and it's if they find a way in how Darktrace then, or it's fundamentally highlights that someone's found that and then what it does about it.
Yeah, it could be that, or it could be someone planting something within the network. Maybe a visitor comes into the building and goes somewhere they shouldn't, gets access to something they shouldn't. So yeah, it can be that, or it can be a compromise on another device, another server, for example.
Okay, cool. Okay, so let's, if you can jump in, Paul, and talk through some of the technology, that'd be great.
Yeah, absolutely. So here we have a Kali Linux VM. Kali is a OS used for pen testing, finding vulnerabilities in networks, exploiting those vulnerabilities. So we're going to be using that for our demo today, and overlaid inside that we have the Darktrace interface. So that will show in real time what's detected as it happens live. So before we've even kind of done any attacks, Darktrace has picked up that there's a suspicious device on the network. It's picked up as attack and recon tools. In this case, it's picking it up because it's named Kali.
So this is, just for my information, I guess, this is someone inside that has a level of, I guess, access, etc., that could do damage because obviously they've got the right level of access into our systems, but they can't because obviously we're noticing that the moment they've installed Kali to do something, we've got it just by the file name or the OS.
The host name. Yeah, it's more associated with pen testing, but yeah, an employee could boot that if they had the correct rights and could start to use it to find other vulnerabilities on the network. So yeah.
Wow. Okay.
So here we're running an Nmap scan, which is a tool used to map out network, find assets, resources to attack, and also scan common services ports. So web services, SSH, common admin interface, various things that device is offering to the network that then can be used to exploit potentially if there's vulnerabilities there. So we'll run a scan against a network here, and we can see what Darktrace sees in real time, what it detects and what it alerts on. So here we're going to do a scan on our one of our ranges, and we'll see in real time what Darktrace detects, what it picks up on, and then what it blocks as well, because Antigena will kick in. So we're running the scan. It's picked up various services here against the IPs.
Yeah.
And Darktrace, in a few seconds, should alert on that.
Can't hold my breath.
Hopefully not too much longer, but it does take, it's analysing the packets.
But this is real time?
This is real time, so we can see it's picked it up here.
Yeah.
It's picked up, we'll zoom in on it, but it's picked up suspicious SMB scanning activity, the attack and recon tools, that was the Kali Linux VM, and it's also...
Sorry, go on. I was just looking at the percentage on your what's the word I'm after here? Are they the thresholds against the threat, or what am I seeing from the percentage values there?
So these are models. Darktrace uses models, and these are model breaches. So it's saying it's exceeded a certain value that its team determines to be suspicious, or there's various levels: critical, informational, compliance, and those are confidence levels. So the higher the level, the more likely that is to be something you need to do something about.
The more confident Darktrace is that this is nefarious and it needs attention. And you should look at it, and we've got, my eyes are terrible, but I'm seeing we've got some pretty high percentages
87% there on the SMB scanning activity. So we can dive into what actually it's picked up on. Why does it think that's suspicious? So we can see here that it's picked up that it's seeing Kali, the VM, try and connect to various IPs on port 445. It's seen a whole sequence of them, and that's enough for it to trip that model breach and to exceed the normal thresholds of, say, a user just connecting to an SMB share. So it's picked up as a scan.
But it also, I guess, it picked up on the fact it was Kali as well, so it knows that's not a normal thing.
In this case, it's just a hostname. So if that was a normal user's laptop and they were doing something similar, it would have their hostname there. So you would just see their name instead. And we can look at the Antigena response. So it's determined that it's suspicious. We've got Antigena with autonomous response enabled. So it's decided it's going to do something about it. So stop it. And it's going to block that traffic. So it's picked up on that model breach, the SMB scanning activity, and now we'll see that it's actually done a block to stop that in real time.
Block that device, block the port. What is it actually taking out of service?
So it will take an appropriate action. So we can see here there's a few the assets that it's found. It's done a firewall block on those, so it will populate a dynamic IP list, and that gets picked up every 5 minutes by a firewall. So that will stop the communication from the Kali Linux VM to the device, to the switch, firewall, server, whatever it may be. And then there's also a network block. So this uses TCP resets from Darktrace itself, and that at the moment it's blocking connections to port 445. So it's seen the SMB scanning activity on 445. The appropriate response is to block or reset those packets on port 445. So it's a response appropriate to the threat detected. It's not just block everything at this stage. We can see also we have the option to extend or clear the Antigena block. So if it is we need more time to be investigated, we can extend that, or if it's a false positive, we can clear it if it's blocking something it maybe shouldn't. So here we're just going to demo the Antigena block. So I'll try and connect to one of the devices that were scanned in the previous Nmap scan. So we'll use the information we've got. So Kali has picked up. It's able to see it before Antigena kicked in. It's able to obviously get that list of assets. But now we'll try and exploit one. So this is just a simple trying to connect to it, but it's going to time out. There's really nothing there. The firewall's blocking that traffic.
It's been the port's closed. It can't get any traffic to it, so therefore there's no connection.
Exactly. This isn't not an SMB attack.
It's
all acronyms in IT. You can't escape them. But it's the firewall is blocking that port now. So it's it's not able to connect to that. And just to prove it's working, we'll go ahead and clear that block and then prove that we can connect to it to evidence that it does actually work. So we'll clear that threat.
So the threat kind of, what's the correct terminology, Paul? You called them something before, with the percentages, etc.
Confidence.
Thank
score.
you. So as part of your team, this is what you're seeing. So if when you're running the SOC and Darktrace picks up something going on in a client environment, that's what it's presenting to you guys. It's filtering out the stuff below a certain score. It knows that it's probably nothing or is certain it's nothing.
Yeah.
And it presents you and the team with, this is above the threshold, this is where your attention needs to go.
Yeah, it's a prioritisation. Certainly some of the lower ones are certainly worth investigating, but if you've got to prioritise these are the ones you need to look at.
Yeah. We've talked about before the noise some of these products make. If you didn't have that and you just looked at everything, there'd be no time in the day to actually do anything with it, right?
It can be overwhelming if you just get a lot of data back, a lot of information back, and it's which one do I deal with first? And there's just no realistic way.
You're going to miss something at that point, and that's where
too much noise.
Yeah, and something's going to get through which is going to do some damage. So that's very clever.
So we'll clear the particular IP that I tested there. We'll cleared that, and we'll just prove that we can connect to it. We'll add there is a little bit of a delay. Our firewall's checking every 5 minutes. So it may take a little bit of time once you've cleared that to actually just detect that it's been cleared. But in our case, it's picked it up, and you can see we're able to. I won't log into it, but we're able to get an SSH connection there, an SSH prompt. So that block has been cleared. So it's a way of stopping attacks in progress and responding to them in near real time. So
the clearing there is if you've discovered that it's highlighted that we think something's not right here, you and the team have looked at it and gone, actually, that is okay, so we'll unblock that?
Yeah, it's either you've dealt with the threat, so it's gone from the network, or it's a false positive or benign positive type detection where it's actually this is normal, it's expected. We don't want to block that.
Now, will the machine learning in that remember that the next time and give it less of a, would it do the same response, or is there a point where it goes, actually, I'm now used to seeing Cali over here, etc.?
There is learning to the models, so it will pick up unusual or rare occurrences and base the score on that. So if something's seen for the first time, 100% rare, for example, it's going to be more suspicious than if it's been seen a lot of times on the network. So that affects the
I guess
scoring.
it's why you have to, the kind of spin up time when we deploy Darktrace, we not ignore it, but the information it gives us for a couple of weeks to a month, it's sorting itself out, right?
Yeah, there's a learning period. So the first time it sees any domain, it's 100% rare. It's not seen it before. So
everything's terrible.
It takes a little bit of time to just learn what's normal for the individual environment that it's deployed in.
Interesting.
So in the background, I've kicked off a download from GitHub. Darktrace has seen that, and it's changed the response, the Antigena response. So it's detected the anonymous GitHub download, unusual for this device. And we can see that it's done a significant anomaly from client block. So the Antigena response was previously blocking connections to those individual IPs, but also blocking connections on port 445. But now the response has changed. So it's also now blocking port 80 and port 443 to limit what that VM is able to do and to reach. It's also enforcing a pattern of life. So that means the traffic is restricted to what Darktrace considers normal, what it's observed from that device before.
Okay, so it's stopping the unusual behaviour, but not all behaviour.
Not
if
all
your behaviour
behaviour
fits your standard pattern, you can carry on.
Yes. So it's a proportionate response to the threat that it's detected. So it's not going to cut off the network completely for, say if this was an employee's laptop, it's not going to stop them working. It's just a response that. Which
I guess it's two ways looking at it. Immediately, I think, well, you should just to stop it. But you are right. There's a lot of stuff that it's seeing potentially. It is benign. And you can sort of stop someone from working every 2 minutes going, oh, God.
Yeah.
But if you just block that one bit it doesn't like and everything else carries on, you're not constantly stopping operations, are you?
No. Your response is proportionate to the threat.
It's very clever. It's very cool. I guess some questions I had then around, because this is one component of the SOC, and we talked before about how there's kind of many components to it. And stop me if at any point I'm making a fool of myself here. But the information we've got here and some of the stuff we're seeing here, this for you guys then feeds up into Sentinel.
Yes, it feeds into Microsoft Sentinel via the log collector, and we can complement this data from Darktrace with other sources. So we can see if, say, an endpoint had at the same time a Cortex XDR detection for any malware on their system. We can pull through logs from the firewalls or from Office 365 sign-in logs, for example. So we can use data, combine data from multiple sources to build a more complete picture of what's going on a user's device around the time of that threat.
Yeah, and we're not going to show Sentinel today, and I've seen it, and I'll be honest with you, I didn't find it as exciting as Darktrace, which is very cool. But it is having that single pane of glass, and like you say, actually taking multiple streams of information from multiple different devices that I guess builds up that layer of knowledge that you guys need to actually action. And this is obviously making some pretty cool decisions, and there's a lot of intelligence to that, but when you start actually taking information out of X and Y and layering that, you guys can work out if it is worst case scenario, we have to stop an operation of a business wholesale in the middle of the night. It's good to have all those different inputs, right, to actually give you that level of information before you start putting the plugs out the back of things, right?
Absolutely, we need to be sure. So having more information is always better because it allows us to make a more accurate decision.
What do you see when you see a confidence score like that pop up?
So I should clarify, Darktrace call it a threat score. We refer to it internally as a confidence score. Higher the number, the more critical that.
The more confident we are, you need to do something.
It's a more severe breach or potentially more severe breach. Yeah. So we'll be notified. That'll come through to our help desk, and we'll review that. So we'll look at the device, and we'll look at what happened around that time of that. So in the few minutes before, we can see if Darktrace, or we can see in Darktrace if there's anything suspicious happening, if maybe it's triggered multiple model breaches.
Yep.
If it's something that we can say that's normal behaviour, that's expected, that user works in that department, they're going to be uploading large files, for example.
Yep. We're aware that person's quickly zipped over to a different country and is working from there now.
Exactly.
Yeah, okay.
Yeah, so we can take decisions that actually that's normal behaviour based on what we know about that client, that user, and that device. Maybe it's something we're unsure of, so we might go to the IT contact at that client site and say, is this normal?
Yep.
And they will go and check, or they might come back and say, yes, that's perfectly normal. Okay. Or they might come back and say, no, we need to investigate further. One example recently, Darktrace picked up a user visiting 100% rare domains, so domains never been visited before by anyone else in that company. They were Russian domains, and we flagged it to the client. They checked, they asked the user, and they were legitimate domains they needed to visit as part of their role within the business. So some things that may look suspicious, and we would think are suspicious.
But that's why I guess you have to have the human element, because you can actually do that verification, whereas if you just left it to Darktrace, it's kind of going block stuff, someone's not operational, but you need the common sense element to go, actually,
yes,
yep, that is part of the job, it's what they need to do to make money, whatever it is, kind of unblock and carry on.
Exactly. And the models will learn. Obviously, that won't be 100% rare next time it happens, but we can also adjust the model logic where appropriate. So maybe it's something that's triggering very infrequently, it's something the user does once a month or once every quarter, for example. We can maybe adjust the logic there to stop that breaching every time.
Okay. So then let's say we do call someone, they say, yeah, that's a problem. I guess talk me through then what the team is doing at that point.
So we're either contacting the client to confirm with the user, or to seek confirmation on how to proceed, or some clients authorise us to take certain actions autonomously. So blocking an IP, forcing MFA, a password reset, for example, shutting a machine down. They've approved those actions in advance, so if we see X behaviour, we can take this action, exactly. So that allows us a quicker response.
Part of the onboarding bit that we set the, I guess, parameters of operation with that particular client.
Exactly.
Understood. So we found something nefarious is going on. We then have permission to stop the service or force an MFA, password reset, etc., etc. Where do we go from there?
So sometimes we might not need to take an action at that time. So Darktrace, as we saw earlier, it can block that traffic. So if it's seeing that behaviour, it can block it until it can be reviewed. So it's no longer it is still a threat in the network, but it's not an active threat as such, because it's stopped from doing what it wanted to do. So if the client takes half an hour to come back to us, it's not able to spread, for example, in their network. We can use that time to confirm whether we need to take this action and kind of stop it in progress until we're able to make a decision on that. But other clients we can just take the action that we see appropriate.
So I assume we take the action, do whatever we need to do,
Yeah.
update the ticket, and then there's a report at the end that says, whilst you were sleeping in your bed, this happened, we did this, and now you're in. There's nothing to worry about, but all this happened in the background.
Yes.
Superb. Okay. Well, Paul, that's, again, really interesting. I always find kind of diving into these things a bit really informative, and it's good to expand a bit on what you and the team do, and I guess how you take these different data feeds and actually use common sense, but also experience. I think it's really important that actually having the right people on the team with you to actually be able to look at this and speak to clients and make those decisions kind of in flight to protect our clients. So look, again, really interesting. It'd be good to get you back on, if you'll come, just to go into some of the other elements of Darktrace, I guess, as some of them are released, we can talk more about those. And then potentially, it might be interesting at some point to go into some of the other elements that we use. I know Sentinel's not the most interesting GUI, but at some point we may want to dive into some of the other elements as well.
Absolutely.
But thank you for coming on.
Thank you for having me, Sam.
Cool. And thank you for joining us on this episode of Krome Cast. Check it out. Remember to like, subscribe and share. And if there's anything you'd like us to cover on future episodes, do leave that in the comments section below. So join us again for Krome Cast. Take it out.